system line I'm
Actually good. Okay, so industrial automation is nothing but you're doing a lot of displays related, right?
yeah. That P10 actually now I am go through. Actually, P10 already some ready-made controllers are coming like
Correct, correct.
Haidu control. With that I am done all so many projects. Today
Ah,
also one big project is going on near that this on harbor. Some 1 feet into 9 feet. One big LED boards are going on 9 numbers.
oh,
Project
nice.
video walls
Great.
like that going. Thuthukudi Harbor, we are supplying
Oh,
5 numbers.
good, super. Nice work.
Right. That is all a ready-made one. So just a model we are connecting and
Yeah.
another way we making the programming.
Okay. But even if you have ready-made program, why do you are getting struggle with multiple displays? The
Actually,
ready-made.
in the customized text we can't able to display. Actually, some data is coming from some UART or something. That data I want to display in that ready-made suitable.
Please,
Actually, one recommendation from the
Jivanandan, please mute yourself. Yeah. Now tell me, Vignesh. Sorry. Yes.
Yeah, no. Actually, one requirement from the Hindustan Unilever (HUL),
Okay.
they want to display the time temperature data. So they will give the temperature data in the 4 to 20 milliamps input. I need to display in the P10 display.
Okay.
The 4 to 20 milliamps input option not available in the any ready-made this high-do controllers. So I need to use the ESP or something and send it to this display. That place only I am struggling now. Normally other places I done with the 7 segment display. Now I am trying with this P10 display also.
Oh, okay. Actually, this is a very simplest one. That is what we
Mm.
getting struggle. If you're using ready-made module, ready-made stuffs, that's very difficult to update that codings or what not all. That's very difficult.
Yeah.
Yeah.
So if ours means everything in our control. That's
Everything in
why.
our control, everything in our hand. We can think whatever we can do. Even we can, for just to do printing a P and display, we can use RTAS. So we can do a lot of stuffs with that.
Yeah.
So only thing is
Actually,
we have to
also
learn.
you've done one board right with the ESP board. Actually, you done the P10 display with the trial run. You done with the ESP.
Correct.
After that, you done with the ESP32, ESP8266, I think.
ESP only. Yes, I did a board with a D1 Mini. It has
D1 mini.
D1 Mini. It is actually it's a ESP32 only.
32 only. Okay.
Yes.
In that, actually, there is a ready-made board with the hub 75 port.
It is not a ready-made board for P10 display. It is not a ready-made board. It is actually controller same like a ESP32. That's it. It's just a
Okay,
controller.
you made that board.
I made one the coding for that. I already know the coding concepts, how to do coding like that,
Yeah.
to blink LED,
Yeah.
scrolling and
Yeah.
letters, everything I know that.
Yeah.
So based on the idea, I developed in the coding the D1 Mini.
Okay. In that hub 75 port, how it is coming? Hub 75 port already.
What is sub 71 board? I don't know that.
Okay.
What is that?
Hub 75. Hub 75 means like FRC connector.
No, that P10 display back side they have connectors. They give a cable, right?
Cable, right? That cable we need to connect with the ESP32.
That's
ESP32 using mini. So how you will connect? For that one baseboard is required, na?
Nothing is required for me because I know the basic coding, right? I know how to control the signals.
Okay.
So I don't.
Okay, we discuss this one completely.
Yeah, sorry everyone.
Yes.
We'll jump into some deep conversation. Yeah, we'll discuss after the class complete. Yes. Yeah. Sorry. Sibaj Khan, can you please explain?
Yes, sir.
Yeah. Yes, your introduction.
Sir, my name is Shahbaz Khan. I am from Sir UP.
Okay.
Presently, I am working in Hyderabad in electronics company as a hardware testing engineer.
Oh, you are auto testing engineer. Okay. Nice. Anyway, good to see you all. I hope in upcoming classes we'll see lot of English other state peoples to come attend this class. I hope, because I want to accept this clearly, because my class for last 4 to 5 years I think, so mostly students in Tamil only, so that I couldn't able to teach in English to our students. I missed that actually, but hereafter I don't want to miss that, so I want to take this chance to teach English to other state peoples to do good stuffs. Yes. Jivanandam, anything to discuss?
So I'm introducing myself. My name is Jivanam.
Yeah, yeah, yeah.
Now I'm currently finishing BE.
Okay, okay.
Similar same time I'm working in application engineer for PLC programming.
Oh, okay, okay.
PLC servo VFD like programmer. I am.
Okay, okay.
And now currently studying that work was too much field work. I going for the too much long side.
Oh, okay, okay.
So
Understood.
I switched my career in embedded application engineer, embedded programmer. That's the reason I studying for the STM32 and the PIC. Now currently I finished and I trying to searching for job.
Okay, okay. How did you
Uh,
finish that? STM pick.
for already I joined on a course from Coimbatore.
Okay.
They're not teaching very well. After I getting video from your
Oh,
side,
okay, okay.
I paid that video and you give that video. I learned that video. Used to learn in STM32.
Oh, then you understand everything,
Now,
right?
yes, bro. That was very nice. I that program used to I can understand further in deeply.
Oh, okay, okay.
Already in joined my course for only teaching hall program.
Oh, okay,
They're
okay.
not teaching for register level, but your video is very nice. You teach in register level,
Yeah, okay, okay.
so I can easy to understand the concept.
Correct, correct. Definitely, it will help you in your
Ah,
life also. Yes, yes.
yes, bro. And after I attend the interview, they asking for the hardware knowledge also,
Okay, okay.
but I don't know about the hardware. I need to studying for the hardware also from your YouTube channel.
Fine, fine. That is my plan also. In hardware time, I will
Okay.
explain everything to you. What are the hardwares I plan to teach
Okay.
in upcoming classes? So that definitely it will be useful for you. We'll discuss one by one. Okay. Okay, guys.
Okay.
So thank you for
Okay.
the wonderful introductions about everyone. So let me start this class. The first one is software. Okay. So let me explain. Uh, Board I have. I think before software, let me explain the hardware first. Maybe it's very important. I think. Let me explain. Wait. Maybe Jivandan also has complete my courses, right? So they will understand. Second. Sorry guys, the camera. Yes, here. This is my board. Are you able to see the board now? The table is a very messy one, but see, fine, fine. Are you able to see, right? Board which I have now.
Yes, sir.
Yeah. Yeah. So before starting the coding stuffs and software stuffs, I just showing my board, development board in front of you, so that you'll understand what are stuffs you're going to learn, what is my plan for the future classes. Everything you'll understand that. Okay. Right. So this my development board. I made it for specifically for online classes. Okay, so I already told in the base in the STM32 board, I teach it for nearly 5 to 6 years, 5 years I think, for working peoples. Please, Jivanandan, please mute yourself.
Oh, sorry.
Yeah, yeah. Thank you, thank you. So the peoples feel like after learning the STM32 from me, right? So they feel like they don't know how to use hardware. You understood, right? They know how to use hardware. That is actually big struggle that people are facing. Same like Jivanandan also told, right? Same thing on that. So a lot of people are learning from my course. Minimum 120, 200 people are learned from my YouTube channel as well as my online classes. But still a lot of people struggling with hardware. So I gave some solutions for that. So I made my own board because we have a lot of STM development board in market. But the problem is they only provide this IC with the board. That's it. So we have to purchase all the components we need to connect with the board. So that's actually very painful start if you're doing very beginner level. It's very difficult to connect. But I plan to do everything in a single board. Okay, if this board itself, you can learn everything. There it has a stepper motor, DC motor, buttons, UART protocol here. You can see some basic IC. I didn't use any advanced technologies here. Whatever I teach to my students, I do a complete board here. And this here it is a sound segment, like dot matrix. This is a dot matrix here. I can easily plug it here. Okay, I can easily plug it. So there is no wire connections here. Nothing. So you directly plug a power supply here. I can flash the coding this IC. Then you can see output. Very simple. So plug and play. Once you see the output, right? Once you see the output, you know how, okay, this is how the output does look like. So we can do with separate another STM32 board. You can easily jump. You understood, right? In this board, I like to explain. Here you have STM32L431. I will tell the correct number while we teaching the next topics. And here we have I2C, RTC, IC is here, and L293 motor driver, stepper motor, and here DC. Okay, L2 motor driver and the UART protocol. Here we have LEDs, PWM, external interrupts, everything's here. Sorry, PWM, inverter is here. And here we have a button, user button, and here external interrupts and temperature sensor, here temperature sensor and the potentiometers for analog readings. So if you use this board, understood it? If you use this board, you can learn 80% of topic here. Then what is the 20%? 20% is nothing but there is a CAN protocol is here, USB protocol is here, and the touch screen, RTOS, lot of topics are there. But whatever learning for basics, to enter in STM32 world, this board is enough, I think, because this is the topics only I teach for last 6 years, right, in STM32, so that people will understand a lot of stuff from this, so that it's very useful if I do like this. You understood, right? So you only need this programmer. So you know this programmer, right? In market they cost around 340 rupees. That's it. With using this programmer, you can directly connect this board and directly flash the programmer whatever you did in the software. Correct, right? That's it. And one more thing is you need some stepper motor you need. Okay, like the stepper motor, directly plug and play. That's it. You directly connect here. If you do a coding for stepper motor, the motor will rotate. The same thing for motor connections. And same thing for servo motors. I think servo motors, here I have servo motor, but it's a damaged one. I use this for some other purpose. But we can use the servo motor like this. So simply you can take this wire and connect it here. So plug and play. That's it. No need to connect any wires. To my learners, to my students, they can easily learn without suffering anything, because the main problem I face in online, right? Let's say Jivanandan doesn't know about hardware, just know it told, right? So what if I tell any wrong connection to them? If we connect wrongly, what will happen? The board will burn. Definitely happen, right? So if I give some ready-made connections, ready-made everything, wire, track everything, pakka. So just need to plug in. That's it. It will work. So that initial phase, the positive output, you can see that in the first stage itself. No need to worry about the wiring. No need to worry about connection, loose connection here. That is my motto. You don't clear it? Clear? Any doubts on this? You can ask me. Yes, thank you. Thank you, Jivanandan. Yes. Shibaj, are you
No, sir,
understand?
no, sir. I
Are you
understand.
understand?
Yes, sir.
Yeah. Are you clear, right? Okay. Are you using any STM32 before?
No, 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 sir. First time.
Oh, first time. Okay. Definitely you'll like this one. Okay. So don't fear about why a lot of wires are there. Don't fear like that. My job is make it simple. Okay. Fine. Nice. So this is how the hardware is working. Okay. We'll come back again once we complete the software stuffs. Okay. Correct. Yes. So I hope everyone know familiar with the controllers, right? Familiar with the controllers, microcontrollers. Yes, right? So simple question I'm going to ask. What is microcontroller? Anyone? Very simple question. Jivanandam, are you able to answer this question? What is microcontroller?
Sir, microcontroller is programming device that was controlling only one device. That program தமிழ் சொல்லிட்டா பெட்டரா இருக்கும்.
Yeah. Not issue, not issue. I will translate. Yes.
ஓகே. இப்போ மைக்ரோ கண்ட்ரோலர் யூஸ் பண்ணி நம்ம ஒரு ப்ரோக்ராம் வந்து ரைட் பண்ணலாம். இப்போ எக்ஸாம்பிளுக்கு வந்து மைக்ரோ ப்ராசஸர் வந்து அதில் ப்ரோக்ராம் ரைட் பண்ணோம் அப்படின்னா அது மல்டிபிள் ப்ரோக்ராம் வந்து ரைட் பண்ணி பண்ணலாம். ஆனால் வந்து மைக்ரோ கண்ட்ரோலர் அப்படிங்கிறது நம்ம ஒரே ஒரு ப்ரோக்ராம் மட்டும் ரைட் பண்ணி அதை பர்டிகுலர் டாஸ்க் மட்டும் செய்ய வைக்கிறதுக்கு தான் மைக்ரோ கண்ட்ரோலர் யூஸ் பண்ணுவோம்.
Okay. But sorry. Okay. Actually, what Sivanandam told, right? So microcontroller is used to flash some simple code. It executed and it controls the external peripherals. That's it. But in the microprocessor, we can do multiple codings on that. It will execute. It will control any other peripherals like that you were told, right? Right. Let me explain from my side what actually it does. Microcontroller. Sorry. Yes. So this is what I told, right? The microcontroller, let me explain what is actual difference between that. So microcontroller, it has own peripherals inside, like I2C, SPI, UART, okay? And everything's inside it. Okay, so we can't change the hardwares. But in microprocessor, it's actually empty. It's empty one, it doesn't have anything. We can add anything we want. That is how the microprocessor and microcontroller is working. That is a very bare minimum example. And come to the point, the microcontroller is nothing but controlling the peripherals. Let's say in my case, right? What else we have now? In the board itself, this is a STM32, and here we have buttons. Okay, let's say you have LEDs here. Here LEDs. So through the STM32, I'm just controlling the LEDs. So microcontroller. So I'm controlling the LED. That is why it's called controlling process. So that is why it's called microcontroller. So the same thing we can do with RTC IC here. We can control the RTC IC from this controller. That is why it's called a microcontroller. It's control the peripherals. Peripheral is nothing but RTC is one peripheral, motor is one peripheral, stepper motor is one peripheral. Like that, it's controlling. So that is why it's a microcontroller. Micro is nothing but small size. Using a small size IC, we can control the n number of peripherals. That is a microcontroller. Very simple explanation. There is a lot of explanations, book definitions are there, but bare minimum explanations, this is how it will look like. Very simple. Okay. Right. So here we are going to use STM. Okay. STM, it's a ARM processor, ARM controller. Okay. I'm not going to explain a lot of theory part now. Let me jump to direct practical, but anyway, we'll discuss a lot about that. Then only we'll understand what is the purpose we're going to learn like that. We'll do. Right. So STM32 is an ARM processor. So ARM processor is used in our computers, phones like that. The architectures are very sophisticated compared to other controllers, other control architectures. So that STM is ARM based architecture. So that for coding process, everything is very sophisticated one. Okay, so you will understand while we're doing a lot of stuffs. Okay, right. So STM. Okay, so STM means they provide a dedicated software for that. The first I will mention here, like to mention here, what IC are you going to use? The IC number is STM32 L43431 RCT6. This is IC I'm using. This IC only I used to fabricate my boards. This board is L431 RCT6. Okay, this is the board I used for the boards. Okay, fine. So for the board, we need this all the softwares we require. Okay, right. And then first start from STM cube ID. Okay, so you may explain this. What is the STM cube ID from your side? Can you please explain anyone? I think Venkatesh know about this very well.
There's nothing but just we need to write the code in this, like Arduino IDE.
Very simple. So IDE is nothing but an editor. It's a notepad editor. That's it. This IDE is a place for you write your code.
Yeah, that's it.
That's it. Very simple. Very straightforward explanation. That's it. Okay, that's a notepad. That's it. They give a place to write a C program. That's it. Okay. Then what is the next step? So after writing your code, we need to compile your code, right? The compiler is nothing but because we wrote our code like this, right? Ash include ash include studio.h, like that we wrote, right? And void main, the print of everything we did, right? So C program is completed. After the C program completed, what we are going to do? We are going to compile the code. We need to get expel from that. Then only we can flash the code into this STM32 controller. So you understood, right? So the compiler is called GCC compiler. This is a very standard compiler for ARM-based controller and C programming stuffs. You understood, right? To do a C programming, we have a CCC compiler. To do this, we can compile our code to generate a X and binary files, everything we can do. You understood, right? Very simple. Right. And next one is STM32 programmer. What's the purpose of programmer here? Anyone? Jivanandam? Any idea?
Sir, STM32 programmer using to generate the code, sir.
STM32 programmer is not that purpose.
Programmer is that is converting lot of storage in file convert to downloading for that controller, sir.
Actually, you சொல்றது correct. You are right. Venkatesh, you know that? I think you know already.
Yeah, actually nothing but actually whatever the program we did, that is in the our laptop or PC something. We need to dump to this code to our microcontroller
That's
STM32.
it.
For
That's
that
it.
interface, we need one programmer, hardware device that is called this STM programmer.
Very simple. Very direct forward. Very direct answers. That's it. So here you can see, right? This is a hardware. I have, right? This is a hardware from ST-Link V2 programmer. So this actually hardware is connected to the lab USB protocol like this. We're just connecting like this. Okay. So this hardware only communicate with the programmer. This software. This software is connected. Okay. So if this, what is the job of the programmer software is taking the X file from the system. This program is also one software. Okay. Taking the X file from the system and dump it into the STM32. Sorry, take it X file from the system. Okay. And the programmer sent the X file to this white color board. ST-Link programmer. This programmer transfer your code to the ST-Link. It's STM IC. So this is how this transferring happening. So X file from your system, it transferred to the white color board. The white color board transfer the X file into the STM32 IC. So this is how its X file is passing. I hope you understood, right? Very simple. Okay, this is how it's working. Right. Even though we can learn coding, we know hardware knowledge. We need to know that. So hardware knowledge is very important here. That is why I directly jump into hardware. Right. Okay. So in my case, STM32 programmer is not working for me. I don't know, for some reason I don't know that. But I used STM32 utility. It's very old one. It's supported by STM official website itself. We can download from website itself. So that's website I'm using because I bought this program in local market. This one. Actually, this original cost of this programmer is 2,000 rupees. But I bought it for 450 or 350 like that in local market. Maybe they give some China product, what it is, something not an official one. So that STM32, it is not able to detect this programmer. So that I'm using utility. Okay, we discuss at last in the session, you will understand. Okay, right. Very simple. STM Cube ID, GCC, and STM32 programmer utilities. So these all the softwares are required. Okay. So first I'm going to start with STM32 Cube ID. This is the software. Just put a name in the Google, so you'll get the software. And this session, I'm not going to explain all the stuffs here. That is very difficult. It's very time-consuming process. My target is to show my output to you. Show the LED blink, how actually LED blink is done. That's it. If you're new to this stuff, so that you can easily understand that. Okay, you'll get happy after seeing the outputs. That is my idea. So tools and softwares here. So here you can see that is the ID Cube ID software here, and MX is a different purpose, but we are not using MX here because MX is a software used to see the IC in graphical way, but everything is available in ID itself. I will show how it's actually working. And Cube Programmer is the programming software. Okay, in my case, I'm only using Cube ID. Okay, we can just click this. Okay, you will get that Windows, Linux, Mac OS download link. I use Windows, so you can see the get software, it's loading for me. Yes, please wait. The website is slow, I think. Yes, please wait. Yes, this is here your download. STM Cube ID Windows. So we can just click this one and get it off software. And one note I need like to give here. So please create an account in this website, like a Google account. Okay, without creating a Google account, you will get some error while creating a new project or choosing any new ICs in the software. So please create a login in this website so that you'll get some proper updates in your software itself. So please create a login. So click accept. Then now it asks create account or download as a guest. So please create an account. It's very simplest way. Just a 1 minute uh, time only is consumed to create account. So please create this. Okay, that's it. So after downloading things, download the stuff. So very installation is very simple. Give next, 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 next. Everything is very simple. Okay, nothing, no need to worry about that. Give next, next. Okay, everything will take care of that. Okay. And what about this GCC compile? Everything come with this HTML cube ID itself. You don't need to worry about anything. Okay, right. And we have to download the STM utility, right? Yes, right. So we have to download utility. So simply go to Google and type STM32 utilities downloads. Here you can see the link for the utility. Click the new tab. Uh, So they actually they provide this product, this NRED. We recommend you to replacement part. Few programmer suggest to use this, but for us it's not as working. So I'm using this still utility, but it's fine for me. So use this one. That's it. Get a link, get latest one, and use this. Okay. So for this one, any doubts on this? The software side, any doubts?
No doubt.
Nice. Okay. Fine. Okay. So software side is that's it. Then we'll move to the hardware side. Okay. Hardware side, I already explained about this all stuffs, what are the stuffs we require. But one thing I like to show my manual for this. I made a manual. Please wait. Yes, this is our manual version 1.2. Actually, my previous board is very bigger one, very bigger for the R&D purpose. I did that board. But after that, finalized the design here. But still, there is some design changes is there in the board. I will do in next version. But the board is working perfectly. No issues. Okay. In the next stage, I'm going to change the regulator circuits and components. Lot of components are backside, like a resistance, capacitance, and backside. I want to bring it in a soft layer. That's what I need to do. And everything in-house only. I did everything soldering in-house to soldering, SMD soldering, everything I know. I did it in my hand only. It takes, for me, it takes 1 hour to complete all the solderings. 1 hour. Because all the components I need to take and place and soldering everything I need to do, right? So backside also some components there. I already showed, right? Some resistance assembly, complete assembly, no through hole here. Complete, mostly I use SMD here, except this ICs, two ICs and capacitance. But everything is most of the connectors, sleeve connectors, but components and are mostly it's SMD only. So that board look very cute. That's right. Okay. So these are the additional components are required to learn this board. First, we need a 12-volt adapter, stepper motor, DC motor, servo motor, and programmer, type E cable, logic analyzer. Anyone know about what is logic analyzer? Logic analyzer?
Yes, sir. That logic analyzer used to getting output signal. That signal, how, example, I2C, SPA, UR, that
Yeah.
signal how to come, we can logic analyzer used to identify, sir. That is basic to we can connect for the another one new peripheral. That is
Correct, correct. Nice.
that was.
That's it. Very simple. Yes. Yes, Venkatesh. You already know this one. Nice.
Yeah,
Nice.
Yeah, actually, logic is nothing but actually we can check in the CRO also, but it is the simplest way. Logic analyzer is the simplest way. We can connect the IOs. For example, I2C is there. If you give clock signal and data signal, it will be merged together, and what is the data? It will display.
Yes,
If we
yes.
check
You're right.
CRO and all means it is time taking process. We need to each pulse we need to check and decoding it take time.
Yes, yes. In the logic analyzer, they give a provision to see the pulse automatically. That's
Yeah,
right.
yeah, that's
So it automatically decode itself. So we can
right.
see the out. We can see what is the pulse with everything. We can see clearly. So that is how it's working. So that's why I gave a pins here. For SP is a pins per here, and I2C here. Now UART is here. So we can directly connect that logic analyzer pins to this pin. We can see the what is the input, what is output data are coming going like that. We can see. So that's why I gave a pins here. Nice, good. So and this one is multimeter is very very mandatory one because without multimeter we can't use some hardware. It's not required for this board because everything's a soldered, everything's a tracked, everything directly connected, coupled with this everything. But if you want to check anything, you can use multimeters. That's mandatory one. These are optional one, but actually it's mandatory. And next one is sorting station because they're using board, right? Let's say you need to do any soldering, you're going to remove any ICs here, you're going to place another ICs. Okay, so that time we need soldering stations. Okay, so it's option one. So if we have, it's actually good for hardware learnings. Okay, and I provide details what are the ICs I used in this board. That's it. And next one is what are the pins I given everything I mentioned here, so that you can easily see and do a coding part. That's it. Okay. So this is how hardware is explained. That's it. Okay. And next one is data sheets. STM32. Actually, there is a two type of data sheet. That's what I mentioned here. You can see from here itself. The first one is reference manual. What is reference manual? Anyone? I already mentioned here, but you can able to relate from there, or you can explain that also. What is reference manual? Shibaj Khan, or you understand what is reference manual? You can also try. Shibaj Khan, are you
yes,
there?
sir.
Yeah, you can also try what is reference manual. Are you able to
Yeah,
give
this
you?
thing I don't know, sir.
You don't know? Okay.
Yes.
Yeah. Venkatesh, உங்களுக்கு தெரியுங்களா அது? Any idea?
No, I don't have idea.
Okay. But anyway, I think Jivanand won't tell you, right?
Sir, yes, I know, sir.
Yeah, good.
Ref- reference manual you should do, we can get the register level all in details, sir.
Correct.
For that IC register level detail. And the
Yeah.
device manual you should do pin configuration,
Correct.
we can get, sir.
Very simple. Very simple. Super, Jivanand. Nice. So reference manual, using reference manual, we can do a coding steps. They actually reference manual itself, they tell how to do coding for any protocol. I2C, a simple GPIO, or XML interrupt, everything they're given in the data sheets itself. That's sorry, reference manual. Okay, in reference manual, they used to call it like RM. Okay, device manual that doesn't call like DVM, but is a different name. But RM is used to short form, they call it in STM websites. Okay, some numbers also there, some serial numbers for data sheets, but we'll see that. That's why it's working. Okay, and I already told, right? I use this IC STM32L4.31 RCT. This is IC I'm using this class. When the reference manual, I put it like a family. What is a family here? What is family? Anyone? Yes, Venkatesh. What is family here?
Actually, this reference manual common for so many ICs, not only single IC, not only this single part number. In this series, some many so many microcontrollers, STM microcontrollers available. All this common data sheet is applicable like that. It's a- there's a family. In this family, all family, this data sheet is applicable like that.
Nice. Actually, it's a good one. Actually, that's what I mentioned here itself. STM32L43XX. In the double X place, you can fill whatever you want. Any number. In market, usually they have CC, they have RC, they have X, or have RW. They have lot of series of numbers is there. R1CC. There are lot of series is there. Whatever series is after 43, you can read this reference manual. But in below the next line, the device manual, right? Device manual, so only for this particular IC, particular series of IC. You understood, right? That's it. This is how data sheets are split in the market. Okay, very simple. Thank you, Venkatesh. Yes. So now let me open STM reference manual for me. STM32L4343 only I put it. I didn't put full name here because reference manual refer family, not a single IC. So I just put a short form of the number, short form of the part number. So STM32L43 reference manual here. I put it here. Here I put it. You use it often because for last, I told right, for last few years, I use this reference manual for my teaching so that it would like to visit often like that it's showing. Nice. Let me open this. Here you can see. You see, right? How many pages here? 1628 pages. You got it right? So it's look like some biggest Mahabharata, biggest big book like that. If you take this printout, it will look like very biggest old book like that look like. So that much of information is there. But we don't need to worry about this much of pages. The reference manual is nothing but refer whatever we require. It is not like a book. It's a reference manual. Let's say you're going to do I2C. So go to I2C topic and read it whatever you want. So it is not a book kind of stuff. No need to read and memorize. It's not like that. Okay, there is a lot of informations are there. Whatever required, that only we pick it and learn and complete our project. This is how it's working. Okay, nice. And so that's it. So let me open one simple example as Jiva told, right? In GPO itself, they have some register and stuff we can do coding stuff. So we have a codings here, registers here to do our programming. So this is the GPO Modia registers. So we have to read this. What is the purpose of Modia? Everything is given here. Okay, you have to read from top. What is a module? Everything they will explain very, very clear. Okay, they didn't use any advanced English like foreign authors. It is a common for all, so you can easily read. The only thing we have to know, we have patience. Data sheets reading is very, very big work. We have to spend some time with that. Then only we understand. Okay, that is actually very mandatory for the STM32 programming. So here, GPO topic is there. We have to read from top and bottom. Try to read. No need to understand everything. Skip through. First understand, skip. Whenever you need anything, go and search again. Read it fully. That's it. This is how it's a reference manual is working. You understand? They provide a lot of block diagrams also, so that we'll understand how actually the circuit is triggered, how actually getting an input, output, everything is working there. Nice, good. So this is how it's working. So do a bare metal programming. We need to know what are the purpose of the ODR, what is the purpose of BSSR. These are the registers. You can see here itself. These are the MODI R, mode R, output type register, and output speed register, and pull up, pull down register, and input data register. Everything's there. Output data ODR register, BSRR register, lock register, alternate functions. Everything's there. So we have to know how to read this and do coding. These are the stuffs we have to know. You understood, right? Okay, this is how the reference manual is working. You can do same thing for other stuffs also, like external interrupts. External interrupts registers also provide. Directly we can use the registers. That's it. All very simple. Yeah. So same thing you can do it for any stuffs like a DMA, ADC, op amp, and timers, and RTC. There are a lot of I2C, UART, SP, everything they have. The audio interface, everything they have. CAN protocol, USB protocol, everything they have. So we have to go and search, go and read it. That's it. No need to worry about the chat GPT, no need to worry about the Google. Everything they provide line by line. Everything they provide in the step by step they provide. The only thing is we have to know how to read it. That patience we need it now. Okay? Nice. Any doubts in this? No, right? Let me jump to this next one. The next one is ref device manual. Okay. Let me open the device manual. For this, we have to type full name of the IC. Then only we get some informations. Otherwise, you'll get that same thing again. The reference manual only. We have to type full numbers, full name. Here we are. The page number is 200 only for this device manual. It only has the specific IC details. See here, what will happen? What for this? You see here, right? This reference manual for this all family, this all kind of ICs. But what about this one? This is only for this IC. Whatever I'm using, this is my board, right? That IC is only they provide here. STM32 L431 XXXX, whatever this IC is supported here. That's it. So here only we can read what are the features are there, like what is the operating voltage, and what is the shutdown mode, what is the current consumed and shutdown, what is the megahertz, everything we can understand from this. Specific informations like a power and number of peripherals, I2C, SP, everything we can read from here itself. Okay, right? Right. And mainly we are using this the device manual only for alternate functions here. That's it. We are not using this data sheets for often. Okay, just use this data sheets for pin assignments. Let's say in STM32 I have this much of pins. The port A, first pin. What are the features are there? So these features we can see, and based on that we can do a coding part. But don't fear about this all the stuffs. I'm just showing the outline. So once we start the complete course, I will tell what is the complete step for this. So you will easily understand that. Okay. And PA1 here at channel 2, and these are the stuffs. These are the alternate functions are there. So timer 3 and these are alternate functions. So PA2 for these alternate functions, everything they provide. Not only port A, they provide it for port B and port C. Okay. port D, and again I think EH itself, but again they put another section because this is another set. 8 to 15 is there. While we learning bare metal, we can go through everything, all stuff. And port A, same thing. So these are the tailor column only we required from this data sheets. That is what I provide. That is what I put it here, like a pin assignments only we use for this using the ICs. You got it right? Any doubts? You can interact with me. You can mute yourself and interact. If you have any doubts, you can ask. Okay. Right. Good. Okay. So now we discussed about softwares, hardwares, and data sheets. Okay. So now we're going to do some simple blinking coding with using HAL library. With using HAL library. HAL library is nothing but I think you feel right. You feel some struggling now also because they provide 1628 pages. Here they provide 200 pages. Totally 1800, 900, approximately 800 pages is there. To do a simple LED program, we need to refer that manuals and we need to do right. That's very painful task. Initial stage. At initial stage, to read all the steps at in one point of time, you will get some bored. Okay, that is why the STM company itself, they provide a HAL library to do our coding very easiest way. It is just a single line. You can do big stuffs like I2C, UART. There is just a single line. I think Venkatesh already aware of that. Yeah, because you're also using the same HAL for a lot of products. So that easily can interface anything with using HAL. But when you enter in the bare metal, you come to know about lot of stuff. How actually it's actually working. What are the tricks we can do to work our coding which is much better. That stuff we can know. So for that we have to work very deeply with that reference manual. Then only we'll understand that. Right. Good. Right. So, but in this webinar, this workshop, I just plan to do a very simple all library coding only because bare metal itself, it takes some time to teach. So I didn't plan to teach that now. Just a blinking LED, so you'll see the output in the hardware so that you'll feel how it's working like that we can know. Right. Let me start this with the LED blink one. Okay. Right. So for that, I'm going to use STM cube ID and utility to flash the program. Okay. Right. So for understanding purpose, you can also download after session completed. If you have any STM32 board, you can try with this. You can blink LED in hardware also. I think you already have board, right? STM board.
Yes, sir, I have, sir.
It's a blue bill or what?
Sir, blue bill, sir.
Oh, blue bill. Okay. Okay. Maybe you can try
Yes, sir.
this. You can try
Yes,
this.
I try, sir, but it's not working, sir. Thereafter, I purchasing for STM32FW407RE, that STM32 board, sir.
Nuclear board. What do you think?
Nuclear board, sir.
Is it working now?
I'm now that nuclear board was working, sir. Blue bill board was not working.
Yeah. Okay, fine.
I
Okay.
also bought for that local um, programmer, sir, device programmer,
Okay.
and that is very simple.
I think
Okay, sir.
recently lot of students are facing the same issues. They bought the Bluebill board. The board itself is not working. I don't know how to recover. That's why I made my own board. Here itself, it won't
Okay,
face
sir.
any issues. Like a board not working like that. Very simple.
Okay, sir.
So this is a software UI. Okay, this is a software UI. So our plan is to do blink LED with this software. Very simple using HAL. I plan to blink LED with this software. Very simple. Okay, the first step is I'm not going to explain all the stuff in the software, just to understand how to create a new project and how to do a LED blink. That's it. This is our goal today. Okay, and go to the file and go to new STM32 project. you want anything extra, I will teach it, but I think I don't have that much time. Because if you start anything new, it takes big time. It consumes a lot of time for us. That's right. Yeah, it starts creating because it needs some update. I think it's getting some updates on the websites here. Once it's update done, we'll start the creation of the LED projects. I hope you understood, right? Go to File, New, STM32 project. I click that. So this is the loadings happening after that. So please wait. It takes some time. Okay. So here the commercial part number you have to write. Just our microcontroller number is STM32 L431 RCT6. That's it. That full number I wrote it here. Okay. So here I am going to click this one, and give next. Okay. And here use default location. I'm going to give my location. You can give whatever location you want, but we prepare with the links of folder structures that help you to do a lot of projects without any confusion in the future. So I create a folder here, STM32 new, sorry, STM32, because all the STM32 folders here, right? So I create another folder here, STM32, and select folder. So here I give project name LED. Okay, LED, and these are the options. I don't need to change anything. Leave as it is default, and click finish. So the IOC is loading. IOC is nothing but that UI. Using the UI, we can visualize the hardware. What are the hardware we have with the board, right? The big STM that IC we can easily visualize, like a GPU, everything we can easily visualize, so that we can understand what are the peripherals. We can easily can do that, like that we can understand. Let me show once it's done. Yes, it's done. So this is how it's working. After creating initial new project, the first time new project created, right? So this is how it's looking. Okay, whatever project you create, it will show the first this images is to you. So this images refers your IC image actually pin notes. So this pin notes, from this pin note we can easily see the what are the alternate function for each pin we can see. You understood, right? So this all is okay. And also we can do hard coding with this. I will show how it's working. And system core is there, and analog and timers, connectivity like ASPI, I2C, UART, CAN, UART, everything's there, and multimedia and security, compounding, CRC, and middleware. The three autos also is there. The fast stepper is the SD card. To do SD card, we can using the multiware. Okay, just 1 second. Yes, guys. So yes, that is what I'm telling, right? So using this UI graphical representation, we can easily understand what is the pin out, what are the alternate functions there, everything we can understand. So we can easily do a coding without going to data sheet again. Okay, right. In my case, I already have showed that user manual, right? Let me open that again. In the user manual itself, I provide that LED connections with my board. In what pin I connect everything I mentioned in user manual. No need to go to schematics. Don't need to confuse anything. So here I mentioned here LED. So LED L1 LED is a PC9. That's it. So port C, ninth pin, the LED is connected. Okay. So here this is a LED. Are you able to see, right? The first pin. I show it in my teaser. This is the first pin. This is the LED is a L1. This is L2, L3, and L4. Sorry, this is a sorry L4, L5. Like that is working. L1, L2, L3, L4, L5. Like that. It's a PWM LEDs. This is a normal LEDs. This a PWM connector means I connect this LED with the timers pins of this. So we can do PWM also with this. And this three LEDs is used to normal LEDs to blink everything we can do. Okay. So the first LED is PC9. Port C, ninth pin. Okay, let me go to this software and here's the UI. So for PC9. Okay, so you have to click this and GPO output. That's it. This is how the hard library is working, right? You don't need to worry about the coding here. You just do what are the configuration first. The UI itself give you direct coding itself. That's it. Okay. So after done this, click save. Click save. That's it. It will give you a code. You understood, right? Very simple. I'm just using this software, STM32 ID. Okay, this STM32 ID itself give you a UI representation of your IC. In that UI, you have to tell what LED you're going to use. Okay, so based on the LED, you can do coding in a simple blink coding in a main.c file. That's it. So here the main.c file is created. After saving this LED.ioc, right, it'll give you a main.c file. In this main.c file, I'm going to do here all GPIO toggle. Toggle is there. Option toggle is there. And port C pin 9. That's it. All delay delay 1000. So 1000 ms is nothing but it's a 1 second. You clear, right? I just do a LED toggling here. I didn't do any complex coding here. I just select whatever pin here, PC9. Got it? The PC9, I did the coding, toggle LED. That's it. I don't do anything here. But in bare metal, what we need to do? We have to go to data sheet, right? We have to see what is output, what is the input, how to set that. We have to turn on the clock. Everything we have to do it manually. And then we have to make the LED on. That is a step. But in all library, all code, just a one line. Just a one line. One line code. Job is over. In most of the companies, I use this one. They didn't go to data sheets at all. Okay, so just using datasheets are all they didn't use actually. But if you know the datasheets, the power of datasheet is you know how actually it's working, so that you can do work very perfectly like that we can do. That's it. And all delays there, just creating some building delays. That's it. So let me flash the code in my hardware. Let me open this camera here. So here I'm going to connect the ST link here, right? Yes. So this is a programmer. The programmer here. The first pin is data, clock, and ground. Okay. The orange color is ground. I'm going to connect this ground pin. and ground, and the next one is clock and data. Clock, data, ground. These are the 3 pins I connected. That's it. And already this white color board is connected to my laptop. You can see some red color LEDs are on, right? That's it. So my job is over. So now go to this one, and next one is I have to power this board. I have a 12 voltage adapter with me now. I will show that here. I have a 12 volt adapter, and it is 2 amp adapter, 2 amps, 12 volt adapter. It's a Airtel some chargers. That's it. Old charger. So here I'm going to connect power to this board. That's it. So LED is on. I remove this dot matrix. So actually in previous class I do that blinking LED. That's why the blinking is happening. Okay. Let me do my coding now. Let me create one more screen. That's it. Let me flash this code. So flashing a code itself is very simple. You have to click this icon, run LED. Just click this. You can see the coding flashing happen. First it start building. First it start creating a compile. Everything is done. Once it's done, the flashing process started. Yes, everything's been built, successfully built, finished. And now it start. Yeah, in first time it will ask what is the configuration, like it will ask, blindly give okay. Yes, waiting for debugger connection. Wait, debugger connected. Waiting for, yes, that's it. Now you can see, right? LED blinking is getting slower now. Because what we put here? We put 1000 here. So 1 second on, 1 second off. This is how it's working. If I put 100, okay, let me build it again. Just click this play button. The ID itself, they provide an option to build the coding to the board. That's it. So now it's again flashed. For 100 seconds, it blinked very fast. You see, right? You see the blinking very fast here. That's it. Very simple, right? Any doubts? Do you have any doubts? Do you have any doubts in bare metal? Do you have any doubts? You can ask anything. Nothing? Jiva, do you have any doubts on this?
No, sir, no doubt, sir.
No doubt. I think you already aware of that bare metal. So that okay, fine. Subhaj, Khan, do you have any doubts? Are you understand right? Did you understand the concepts? Subhaj Khan? Think it's not there.
Hello? Hello?
Yeah. Do you understand the concepts?
Sir, how to open this hall option?
Sorry. How to?
How to open this hall option? This hall window I open now. This
This hall toggle, this one are you asking about? This one?
not this one, sir. This full window, sir.
This one, like this. I couldn't understand. What's the question? Full window means I can understand.
Sir,
They
hall
asking
window,
for
sir.
how
Hall
to.
the library, enough for library.
Library, what library used?
So no, they asking for how to create a new project. Idea asking. Sir.
Do you want to create new projects, Rajkan?
Yes, sir.
Yeah, new projects are not very different. Simple, right? Go to file and go to new and click STM32 project.
Okay.
After that, it will ask to enter your part number, like IC number, as I tell here, right? This number.
Okay,
This
sir.
number you have to type and select and create new folder wherever you want in system, and it will create. That's it.
Okay. Okay.
And after that, it will open here led.ioc. This file will open automatically. After that, you can select here. In my board, I have this LED is connected to this port.
Okay.
In my
Okay, sir.
board, development board. So I selected this pin as a output because LED is a output, right?
Okay. Okay.
So that I created it, and after click save. Once you've done this changes here, click save, Control yes, or click save here also, and go to main.c and type toggle function. That's it. The LED is blinking.
Okay. Okay, sir.
Very simple. And 100 millisecond delay. Okay, but this is not actually embedded. You understood, right? I just showing the positive output here. Positive output. But our actual motto is to learn bare metal. Bare metal is nothing but open the data sheet and read line by line what are the steps we have to do, everything we can do in data sheets itself. That is our motto. But I just showing the examples how actually it's working, everything. Once I start the master class for this with the hardware, I will give you hardware also for this class. So you can do it from the remotely. That is my idea. So this board is not only for me. I plan to made this board for everyone. Okay. So for everyone. So once the class started, I give it to the board to everyone. The fees for the full calculate for the same for this board also. So once the class started, I give this board so you can train from this board itself. Got it? So hereafter you'll get some hardware knowledge after that. And also in this board itself, I provided 6 pins here, 6 extra pins, so that you can easily connect any other LEDs in outside like a breadboard. We can use this breadboard like the stuffs. We can connect LEDs from outside. That's it. Right. Anything you need to ask? Any questions?
No, sir.
No. Right. Okay. Yes. Okay. Nice. Actually, this is my planning. I actually complete whatever I planned now. I completed. As soon as possible, announce the master class for this STM32. So I hope everyone will join. I plan to conduct English and Tamil separately. Okay, so Tamil students will come, so Tamil classes separately, and English students will come, other states will come separately, so that everyone can learn and understand the topics. Okay, right. Any feedback about this class? Are you guys have learned anything new? Do you have any questions? Please ask me. I will explain. Yes, Venkatesh, tell me yes.
Yeah, it is okay, sir. Actually, one small doubt. Now we loaded the code. Now, actually, we are not converting to Xcode and loading. So just
Yeah.
directly we are loading. Now,
Correct.
power of it will be continue the previous code or it will be vanished.
No, actually, this coding is not erased when you plug
Okay.
off and plug in.
Okay.
Because actually what happened, right, in the HTML cube itself, it's creating a DLF file, ELF. That one type
Okay.
of files like a X file. That ELF
Okay.
file
In
is
background, it
generated.
is running like creating.
Yes, the hardware directly is flashing through the HTML cube itself. It doesn't require X file. That
Okay.
is
Okay.
the
Fine.
provision they provide. But sometimes we need X file, right? There is a
Yeah.
provision for that. I will explain that also later.
We need to explain.
We need expect. I will tell the example. I will tell the steps for that. Then only we need to use a utility, right?
Mm-hmm.
I will tell the example. Good question. Right. For the first step is go to project and property and go to C++, C and C++ build and settings. The settings itself, they give options like a post build outputs. Click this one. And there is a two options there. See, they provide a lot of options. Intel X file. Click this one. It's give you X file. That's it. Default, it's untick, so it doesn't create anything. It only create ELF file, but we need ELF file for our project, so that click this. Okay, and click apply, and click apply and close. That's it. Now no need to click this play button. Just click this hammer icon. So just click this. You will get expire. Okay. All right. Now we'll get expire here. Where is my camera? Camera is not there. I'll open my camera. Sorry. Audience, you can mute yourself. Some background noise is there. I think we are from outside. Yes. So you can see some LEDs are blinking, right? Even if I remove the power, okay, it's now already off. If I connect this, LED is on. So coding still is there. It's not erased. But now you're asking about expel, right? Expel is there. Expel is created. Previously it's not create. Now it's created. Now I'm going to open the utility. Utility is old software. The website itself they told please use updated software like that. But we're using some Japanese products. We are depend upon old devices. That's it. And here the first step is click this one, program and verify. The utility is nothing but programmer. So expel is created. That expel is transfer into your hardware, right? Your hardware here. You have to transfer that. See that for that we have to use utility. It's a programmer stuff. That's it. And click this program and verify. Okay. Click this one. It will open this tablet like this. Sorry. Oh, it initially is open. Fine. So it's open like this. Now we have to go to the our project folder. There's 32 two. Nothing is there in here. I think it's creating two new fold sections. This is what I create, but nothing is there. I think fine. Maybe the folder names are not given properly. But anyway, fine. Debug is there. Let me check. Yes, this LED.txt is loaded. There's nothing. No need to worry. You see, right? I create in new folders only. In new folders only I create an LED project is there. That is why I put it here. In new folder, debug.x. Whatever you get it from the Excel from the software, right? You'll just put the path for that. That's it, like this. Browse and LDX and click start. That's it. Now you can see LD is blinking fast. You understood, right? Very simple. Let me do one thing. If I put 1000, okay, let me build it again. It will give you another X file. Okay. So here you have to go again, program and verify. Go to browse. We have to do it every time because it's not taken updated time. It's have to do it manually. So this is the latest X file. Click this one and click start. That's it. Now you can see, right? 1 second on, 1 second off. That's it. This is how it's working. Okay. So in your working environment also, some people are asking please provide X file. So that time we can enable the X file and give to them. That's it.
Yeah, thank you. This.
Yes. So that's it. Fine. Okay, guys. So that is how my planning is fine. Yeah. Any
Sir,
feedback?
I have one doubt, sir.
Yeah. Please.
Expel you should to we can debug, sir.
Expel, we cannot debug.
You should to we can able to debug, sir.
Expel is used to flash the file to the STM32 out. That's it.
Okay, sir. Okay.
Debugging and all, we can do it from cube ID itself. I'm just closing this. Okay. Let me show how to
Okay,
debug
sir.
it's happening. Here the bug is there, right? Bug symbol is there. Debug. Just click this.
Okay, sir.
Okay.
That
For
was
this,
already you teach, sir.
oh, okay. For this, you have to connect this
For
programmer.
that, okay.
A program is going to connect and it will debug line by line. We can debug. Debug is nothing but we can verify each line is executed or not. We can verify. Okay, let me show that also.
Okay, sir.
Go to SFR, GPIO, port C, right? Port C, ODR, OD9. This is our pin. Initially, it's a high only. Okay. if I go step by step, you can see that also. You can see here, it's high. If I do next one, now see it, it become 0. Let me show in a real outdoor also. So you can easily understand. Now the LED is not on. If I do it next line, LED is on. So you can do live executions. It doesn't require X file. It only required ELF from the IDE. With X file, we can't debug. With ELF only we can debug. You can see, right? So step by step we can debug. Step 1 goes to delay, and if I do this, LED is off now. Again, if I press again, LED on. So we can do live executions. Okay, nice. Any doubts?
No, sir.
Okay, nice. Okay, guys. So this is how I plan to take. I just to show my board to everyone. This is my plan, and show that, and also I explain the basic stuffs. How actually is, what are the softwares are required, what is the hardware is required to start learning STM. Everything I shared. I hope it's very useful to everyone. Okay. So if you like to, guys, please give your feedback now. So I'm very happy on this. Any feedback about this class? You guys are really learn anything new, or it's look like very old one like that.
Sir, already I learned your STM32 that class, sir.
Okay.
So this is okay, sir. I revised that already learned that I revised now. That is okay, sir. We will, sir. But I want to. I gone for one interviews. Two. I gone for 5 interviews, sir. 5 out of 3 they asked me for the hardware knowledge, sir.
Okay.
ஆஹ் நான் தமிழ்லயே சொல்லிடுறேன். இப்போ அவங்க என்ன கேக்குறாங்க அப்படின்னா, இப்போ ஒரு எல்இடி வந்து இப்போ எக்ஸாம்பிளுக்கு வந்து ஒரு மைக்ரோ கண்ட்ரோலர் இருக்கு. அந்த மைக்ரோ கண்ட்ரோலர் வந்து நான் ரிலே மூலமா ஆன் பண்ணணும். அது வந்து 24 வோல்ட் ரிலே. அதை வந்து எப்படி ஆன் பண்ண வைப்பேன் அப்படின்னு சொல்லிட்டு கேட்டாங்க. நான் ஆட்டோ கப்ளர் போட்டு சும்மா பேசிக்கா வந்துட்டு யூடியூப் பார்த்து இது பண்ணாலும் ஆட்டோ கப்ளர் போடுவேன், இல்லைன்னா டிரான்சிஸ்டர் போட்டு பண்ணுவேன் அப்படின்னு சொல்லிட்டு சொன்னேன். அது நெக்ஸ்ட் ஸ்டெப் வந்துட்டு அந்த டீப்பா போயிட்டாங்க. இப்ப அந்த இடத்துல வந்து ஒரு டிரான்சிஸ்டர் போட்டோம்னா அதுல இருக்கிற ரெசிஸ்டர் அதுக்கு என்ன கெப்பாசிட்டர் போடணும், அது ஸ்விட்சிங் பண்றப்ப வந்துட்டு ஒரு ட்ரிகர் ஆகும், அந்த பல்ஸை வந்து அரெஸ்ட் பண்றதுக்காக என்ன வேல்யூ கெப்பாசிட்டி போடுவேன் அப்படிங்கிற லெவலுக்கு வந்து கொஸ்டின் கேட்டாங்க. ஆக்சுவலா நான் இன்டர்வியூ அட்டன் பண்ணது வந்து எம்ப்ராய்டரி சாஃப்ட்வேர் ப்ரோக்ராமிங் தான் அட்டன் பண்ணேன்.
ஓகே. ஓகே.
ஆனா அவங்க அந்த அளவுக்கு கொஸ்டின் கேட்டவங்க எம்ப்ராய்டரி ஹார்ட்வேரும் வந்து அந்த அளவுக்கு டெப்தா தெரியணுமா அப்படின்னு சொல்லிட்டு இப்போ நான் எம்ப்ராய்டரி ஹார்ட்வேர் வந்து ஒரு டூ 2 months வந்து நான் இப்போ அப்படியே பேசிக்கா லேர்ன் பண்ணிட்டு இருக்கேன் சார். ஜாபுக்கு போயிட்டு.
Oh, now you're working. Are you working now?
Yes sir. Now I am working PLC programmer, sir.
Oh, PLC. But you're
PLC,
looking
sir.
for embedded, right?
Yes sir. That PLC programming was I need to go for site, sir. Daily I going for one place. That was I facing difficult, sir. I don't like that job, sir.
Oh,
Salary was okay, but I need to go for the site. That was the reasons I hate that job.
oh, okay. Okay.
That is the reason I switch to embedded software, sir.
Fine.
That
Actually,
is the reason I
embedded
learned, sir.
software alone, you don't have that chance to join. But embedded software, but hardware is there. Lot of job is there, so that you have to do a lot of hardware knowledge. You have to get it. That's it. So try to answer the questions
Okay,
so
sir.
that you will understand a lot.
Okay, sir. Okay, sir.
Yes.
Do you conduct for the hardware also, sir?
Yes, for STM, I plan to conduct a hardware, like
Okay,
hardware
sir.
executions and all. Not electronic side.
Okay.
Not in electronic side.
Okay, sir.
It's only in STM hardware. So directly we can do projects with that. Like that we can make a plan.
Okay, sir.
Okay. Yes.
Okay,
Nice.
sir. Okay, thank you, sir.
Yes. Any other feedback?
Yeah, this Venkatesh. Actually, I used this STM32 like that mini type board, development board, very long back. Even 5 years back, I used it. Now I'm seeing this all are something I learned new like that. Even I don't know this ID also used very long back. I forget everything. Everyday practice now we are using Admega, ESP. All project I know now I am going with the ESP only.
Oh, okay, okay.
Totally, it is different. Now it is looking very new. It is something I'm learning in this section also.
Oh, nice, nice. Thank you, thank you. Yes, I think, thank you so much for your feedback, valuable feedback. I'm very happy to hear all your feedbacks. I think Shiva Raj, I think, spent some internet issue, I think, but anyway, I hope everyone happy with this class. So please let your others to know this celebrating this class so that they will join and learn a lot from this. Okay. I plan to do a lot of hardware stuff in futures like inverters, ATAs, a lot of hardware stuffs also. If I turn any projects in that, I will share definitely share like a feed and display. I put it a post in Instagram, WhatsApp, YouTube, everything. I put it so that you can see and ask any questions on that. I will answer on that.
Yeah, actually, in P10 only I doubt. Actually, you have I need that hardware. P10 hardware.
Okay, okay,
With the level converter is there, na?
okay.
That hardware. Can you able to show photo now?
What? Yeah, in screen I have to share. Okay.
Yes, yes.
Ah, what number is that? STM?
Not STM. I am telling about this P10 display hardware.
Oh, okay. Feed and display. Okay.
No. Whatever you are having on board, na that one. Display boards I am modules I am having. That microcontroller hardware I am telling.
Oh, what board is that? Name?
No, no. Actually, whatever you are using now, how you are connecting a P10 display with this microcontroller.
Direct machine.
ESP32.
Direct merchant. I didn't use any level shifter here also.
Oh, okay. But logically it is wrong, na. Actually, P10 display is the 3 point display is the 5 volt input. But our ESP is you are using ESP or STM32.
Both I used actually. Both I used.
Yeah, STM32. What is the IO level in STM32? 3.3 volt, na?
3.3 volt, yes. Actually, ideally, it should, we have to connect that voltage level shifter to translate to 5 volt and 3 volt, whatever it is, it should connect
Yeah,
like that.
yeah.
But in my case, I didn't use that. Maybe it may be
Even though
dangerous.
it is working.
Dangerous in future, but I don't know. In my house, I have on display for last 4 years. It's working. In my
Okay.
last 4 years, I didn't use any level shifters.
Okay.
I showed in YouTube, right? And on displays, I used to do a real-time clock with the ESP32, EA2,
Can you show me
A266
that
like
one
that.
only? That one only I want. Can you show that one?
Yeah, please wait. Yeah. I didn't use voltage level shifter there, but for last 4 to 5 years, it's working for me very well. Where it is? Oh, in the here.